Hello, you're listening to the Project Catalyst podcast with me, Kim Clyden. The saying necessity is the mother of invention is derived from Plato's philosophy that our need would be the real creator. This is true of all innovation and something Project Catalyst members know very well. There are countless stories of farm machinery engineered in growers' sheds to suit a new practice or need, and we continue to pursue new ideas. Whilst coming up with a revolutionary idea takes creative thinking, engineering a prototype and protecting your idea under IP takes a little more. Resilience, tenacity, and critical thinking from an entire team. So how does a concept get to a global market? And why should we embrace the smart economy here in the regions? Ryan Norris is the Managing Director of Veyron, who travelled from Zimbabwe to Australia with his parents aged 6. Ever curious and intrigued by inventions, Ryan pursued a career as a mechanical engineer. As a graduate working in conveyor maintenance for big mining, his inquisitive mind led him to a life-changing discovery.
Conveyors are a system of components that all work together, and there's lots of subcomponents to a conveyor system, and you've got your belt, which all the material, the ore or the coal or whatever sits on top of, and that moves from one point to another, and that's driven by drives and gearboxes and all these other subsystems. But what supports the belt on its journey is a series of rollers, and the rollers are not like you would think about in a baggage handling situation or at the airport when you're going through the X-ray machines. These are big chunky pieces of components that are treated as a wear item because they exist in huge quantities. So there's thousands of rollers on a conveyor system, and they're very, very difficult to track and maintain and monitor just because of the sheer quantity and access constraints and ability to actually see all the rollers in the conveyor system, because you might not be able to get to certain areas because it's dangerous. There's a lot of rotating components or areas where access is difficult because of heights or things like that. So what happens is these rollers end up failing because a mining environment or a bulk materials handling environment, that's the general term for all forms of moving huge volumes of dirt or material. They're dirty environments, and these components fail. But when they fail, they become a fire hazard. Failure of the rollers is the number one reason for why fires start on conveyor systems in no matter what. If it doesn't have to be coal, it can be any kind of conveyor operation. That's because a bearing will fail and seize and overheat, and there's lots of friction and things catch on fire.
And you've got lubricants as well.
That's right, greases and lubricants that can catch on fire. But they can also kind of degrade and collapse, and then you get like a broken roller that then starts tearing into the conveyor belt. And the conveyor belt itself is the most expensive item in your conveyor system in terms of like capital outlay. It's a protected all costs aspect to the conveyor. And so the one client we were working with had a 2.5 kilometre conveyor. So on 2.5 kilometres, you've got roughly 8,000 conveyor rollers. And the belt was worth about $20 million. And they got 4 years into running that belt, and they actually had to write it off, scrap it and throw it in the bin because the rollers were failing unmitigated and a lot of the times undetected, and tearing the belt. And they actually had a couple of fire incidents as well. You know, the odd roller that fails and causes a bit of damage, you can repair and patch. But if it's happening all the time and going unnoticed, that damage is accumulating. And on this one particular belt, that accumulated to the point where they just couldn't repair it anymore. It had to be entirely replaced. So that was a big eye-opener for me, because our company was contracted to inspect this conveyor system and try and manage the problem. And no matter how hard anybody tried, it didn't seem to really affect things. And when I saw the dollar figures attached to the problem, I said, this is a massive problem. Why is it? Surely you can solve it and eliminate this as being a factor. Like, why are people just putting up with it as a cost of doing business? So on one of my inspections, which can be like 10 hours, you go down underground, before the sun comes up, and you're sort of coming up after the sun's gone down, so you don't see the sun, sort of thing. My mind got to working and thinking about how this could be comprehensively solved. And that sort of put me onto the train of thought that perhaps you could embed sensors into these rollers and allow the roller to monitor itself and eliminate entirely the need for any person to manage that. Because when people are involved, it's ad hoc, it's laborious, and it's also prone to human error because a lot of the time I'm inspecting these conveyors and I'm not looking at the conveyor, I'm looking at my feet so I don't fall over and trip into the conveyor. So that's kind of where the concept came about, is exposure to conveyors and those problems and the headaches and the costs.
By your own admission, you're not necessarily into the technical aspects of things like sensors. You're a mechanical engineer.
That's right.
So how do you go about then finding the types of components or the information or even the technology that you can then make that idea a reality?
It consumed me for a good few months while I was still in my job. In all my spare time, I was researching because I thought surely that there's something. So I basically devoured the internet looking for what's out there. And that was a huge educational exercise as well, because I quickly found that there was nothing out there that was addressing the problem. But I was also learning more deeply about the problem and about rollers and all the different brands and the way the market works and the who's who in the marketplace in terms of conveyor component manufacturers and conveyor vendors and suppliers and what the global market looks like. And realizing and it dawning on me that this is a huge global opportunity, essentially. And just because I've got this problem here in Australia does not mean that it's not also occurring elsewhere in the world. I mean, it's a common conveyor type problem. And then I looked into technologies which might be able to assist in being applied to solve the problem, not really coming up with much that couldn't be done without building something from the ground up. So then I realised I'm probably going to have to engage somebody to build this product for me. So being an engineer, I wrote a full product spec, essentially, probably a 10-page document which outlines the problem, the technical aspects that the technology needs to have to address the problem, specifying the technology from a conceptual perspective. And then I took that to engineering firms from around Australia, electronics engineering firms from around Australia, people that had the competency that I didn't have, and requested quotes. Some people never responded, and I got some quotes back, and I quickly learned that I was wanting to play in a different league. I could not afford, nowhere near on a graduate salary, what just the first prototype was probably going to cost me. So I was quite disheartened by that, and I thought, well, it's a great idea, great opportunity, but this takes money to make money, right? How the heck am I ever going to undertake this product development? So I kind of forgot about it for a little while, and a number of weeks or months went by, and one of the firms got in touch, and the guy called me and he introduced himself as the owner of the electronics design firm. And he said, I've seen your product spec and I noticed that my office has quoted you guys. Are you going to do the project? And I said, I'm a graduate. I haven't got budget for it, so sorry, I can't. And he said, I see people propose product ideas all the time. A lot of them, it's written on the back of a napkin sort of thing, and you kind of take it with a grain of salt. But you've really outlined the business opportunity here, the technical requirements. It's very rare for me to see in terms of what people generally come to us with product development projects with. He said, I think we have to build this. And I said, but I told you I can't afford it. And he said, well, would you be open to doing a deal with me where I subsidise, the cost and halve it essentially? He said, would you be able to scrape together the other half? And I said, maybe, I don't know. And he said, well, if you can, I'll go in with you 50-50 and we'll build it together. I get home and I say hello to Nicole and I say hello to Mum and Dad and I say, I just had this phone call, that idea I had. Well, this guy's rung up and proposed that we build this and he'll come in with half of the money we needed. And everyone just went, oh, who is the guy? So I Googled and showed them the internet, the website for the business. And they went, oh, you don't get this kind of offer every day. You should really think about seriously doing this. So I got a lot of encouragement and support from home. And I said, but even half of it, where am I going to get that money from? And Mum and Dad
What sort of money are we talking about?
So at that stage, it was a $180,000 thing. But that's, in my mind, $180,000 to get me a finished product. $180,000 got me the beginnings of a semblance of maybe something that might work as a prototype.
Wow.
Yeah.
Your half would have been 90 or 180?
No, my half would have been 90.
Yes.
But yeah, I didn't have any savings for my name.
It's still a lot of money.
Yeah. I was
That's an annual wage for most people.
I was a 21-year-old graduate engineer that went to the pub every weekend, so no savings or anything like that. But fast forward to today, we're approaching $10 million on the business. So that's the kind of orders of magnitude naivety that we had, 180,000. Even my business partner, who's the guy from the product development business, probably was caught off guard by actually, because we're building something from the ground up, breaking new ground, and there was
So their quote really didn't hit the mark anyway.
No, if I had the 180 grand, I would have been very disappointed with what I got at the end of it, and there's a story behind that too. But anyways, Mum and Dad said, we'll give you a bit of a loan and help you out, and I had a boat at the time which I sold for 30 grand, so I got 30 grand together, and then. It was funny, the credit card companies are very more than happy to extend your credit card limits. So
it's true.
I got another 30K together on a credit card.
Wow.
And then Mum and Dad come in with a bit of money as well. So I cobbled together the cash and a personal loan as well. So I was hooked up to huge amounts of debt. And I was kind of like building the plane as we're falling towards the ground sort of thing, because I didn't get all the money together in the beginning. I got Mum and Dad's loan to kick things off, which funded the first month's work sort of thing. But then during that month, then I worked on the personal loan and got the personal loan, and that kept me going for another couple months. And I was saying to Paul, my business partner, the whole time, yeah, I've got the cash, I've got it all together, but I hadn't. But I knew we had to start ASAP sort of thing. Didn't want to lose time and stuff him around with working and trying to get 90 grand together.
I think you need to be confident, though, when you're stepping into that much risk.
I was on autopilot. I think I blanked the risk out sort of thing, because I was that excited by the opportunity and knew it had to. Someone's given me an opening. I needed to capture that opening at all costs sort of thing. And my fallback was, what's the worst that can happen? I'm a 22-year-old with 90 grand's worth of debt. I'm sure I'll recover.
That's the way you've got to think, though. This is where startups and entrepreneurs excel, because all you can see is this design concept and its application, the fact that there's nothing else out there doing it, so you've got an opportunity. And when I think you see things as an opportunity, this is what gives you that bravado and that win-at-all-costs attitude.
Yeah, it was like, what have I got to lose? You evaluate the downside, you look at the upside, and I could not drop the idea and concept from my head. It was all consuming type thing. And I tried every which way to try and kill it in my mind and think about why it might not be a viable thing to do, and try and be grounded in some sort of rational sensibility. But I still couldn't kill it, so I knew I had to do it sort of thing. And it was just this weird autopilot mode the brain was on, which kind of like numbed out the fear of being 90 grand in debt at 22 sort of thing. And I'm sure there are other 22-year-olds that get into a lot more debt and buying cars and boats and things like that, but you've got something for your money there, whereas this is 90 grand that you potentially walk away with nothing for your money.
So how long was it till you had a developed prototype?
So that process took another year and a bit. You start the R&D exercise, and then Paul comes and says, we've actually learned that this is something we didn't factor in, or it's a lot more technical, so we have to investigate this and develop some intellectual property here to feedback. So it ended up taking a good while to actually get the first prototype. And that prototype was a very, very rudimentary proof of concept that maybe we could then ultimately produce something that will work one day. And I was very disappointed. I was naive that, 180 grand I thought would get me my business and we would all be millionaires overnight. But no, that was...
that's the dream.
That's right. And it doesn't work like that in
reality. It doesn't.
So anyways, we got this prototype together. I remember we actually did a trip back to Zimbabwe as a family. So we were in Zimbabwe over a Christmas, and I got an email with the first renderings of the prototype, and I was pumped, like so excited to see visually like what they had developed. The prototype was great to see, but I could also see that it's potentially not going to be something that's commercially viable, and we're going to have to flesh it out a lot more. But I was still pumped to get to that point. And then we built the prototype, so there was money in building it. So I approached some conveyor companies that make conveyor rollers, and I I said, we've got this technology and you can embed it in your conveyor rollers, and suddenly you've got a smart roller and you're going to eliminate all your mining customers' headaches, because nobody has developed, made any significant innovation in conveyor rollers for decades, and now this is going to really sort of like revolutionise you guys. So a bunch of interest came from conveyor roller manufacturing companies, but one especially from Western Australia that makes hundreds of thousands of rollers every year and sells them to BHP and Rio Tinto and all the big name companies out there. And that's really what accelerated things. So they said, well, come to WA and we can look at maybe partnering up with you guys. We were like pumped. We thought, this is it. This is how they're going to pre-purchase, and we're going to get some cash in the door, and we're going to finish building the technology. So we took the prototype and we flew to Perth, and the night we get to Perth the day before, and that night at the hotel, Paul and I making sure it's all going to work, and we fit it into a demo roller, and this roller needs to be spun as if it's in a conveyor.
Working.
We're spinning the roller with the sensor inside, and we just hear this crunching. Yeah. So you stop the thing and we open it up, and it's in a million pieces. It's just being crunched up inside. It was such a rudimentary prototype that it just was laughable to think that we could put it in a roller, spin it at 300 RPM, and for this thing to... And so anyways, it was broken, and this is the day before our pitch and presentation to the conveyor company. I think we had an all-nighter trying to patch things together and fix it, thinking that we might be able to cobble something together. But even that was a write-off. The all-nighter yielded no results, and we're like, So we go along to this meeting empty-handed. We did have a video, though, where we had previously filmed, hey, look, we got the prototype working and stuff like that. And here's some videos of us doing some tests and experiments with it, and it's producing data and look.
Fantastic.
So we had these videos, and we took those videos along, and we said, look, the truth of it is we actually destroyed the prototype last night. They bought in. They were like, okay, we can see you've got something. I mean, you've got a lot of work to do before this is something we can sell or use in our products, but in principle, we're in as a developer. We will buy this when you're ready. And we said, well, and they said, what do you need from us? And we said, well, the thing that will get us to the next stage is probably some kind of letter of intent from you guys. So they produced that letter for us, and then we're like, Paul and I were like, we need more money. We spent 180 grand, and all we got is 1 million pieces broken inside a conveyor roller. Even just building another prototype is another few $1,000s, which I can't. And so Paul's like, all right, well, we've got to raise some cash. And I had no idea about raising money from investors and anything like that.
Not even government, R&D grants and things like that?
I was that green. I knew nothing about any sort of grants. Now we're grant pros. We've had so many grants. But we took that video footage of the prototype, we took the letter of support with the conveyor company, and we Googled literally like how to raise money in Australia, and angel investors came up as an option. What's an angel investor sort of thing? Oh, okay, well, an angel investor might be able to back us in this early stage of the business, and this is exactly their sweet spot. They don't invest in later businesses, they invest in earlier businesses. What do you need to do to impress them? So then you get to like almost like a how-to guide sort of thing from okay, well, let's just do that then. So we registered our business opportunity with a whole lot of angel groups from around Australia and got responses from a couple, being Melbourne Angels and Sydney Angels, and invited to pitch. And we went to Sydney Angels on like a Wednesday night. Many months has lapsed between that letter of support from the conveyor company and pitching to Angels, I think almost a year even. So we get invited to pitch at Sydney Angels, and we go there and we pitch. We broke the record at Sydney Angels for the most amount of angel investors that want to invest in a single deal on a given night. We were just like, minds were blown, on cloud nine sort of thing. And the next night, it was the Thursday, and we went down to Melbourne and pitched there. They never said we broke any records, but we definitely had a similar show of hands
support
in the room. And interest across two angel groups, we ended up being able to strike a really good investment deal. Taking the money from Melbourne Angels seemed like a better fit for us, and raising seed capital, which is $500,000. And that's pure seed. It's like they've gone, you don't even have a product here. You've got some videos of a product that you used to have. You've got a letter of support, and even your company structure is not right. You're going to have to restructure your company structure to be investable. So yeah, we'll invest $500,000, but you have to rejig a couple of things and you get the money. So
See, half of this is already too much for me. I think I would have been out,
Yeah.
many months or years prior to reaching this stage. What kept you going?
It's a good question, and I don't know if I have the answer. It's just something kept me going.
Your belief in this
Yeah.
product, obviously, and,
Yeah.
and your idea and the fact that it wouldn't let you go.
Yeah, that's it. It wouldn't let me go. There was always forward progress. Even the destruction of the prototype, that's probably a backward step, but the fact that the next day we still had interest from the conveyor company was indication that we're on the right path. So as long as I kept getting the signals that we're on the right path, why stop? Like, it doesn't even, that's not logical to me. If all the signals are you're on the right path, why would you stop?
So you got your seed capital.
We got the seed capital.
You're back in Mackay.
I then said, all right, we got seed capital and funding, but to really kick this up a gear, I need to be in the office with Paul. So I moved to Sydney. In hindsight, I forgot about organising accommodation. I was so focused on kicking the business off. I get there,
Love it.
fly into Sydney, go to my partner's office, and then he goes, where
Are you staying?
Where are you staying? I said, actually, I don't know. I've forgotten all about that. So I booked in at Meriton down the road. It cost me an arm and a leg because it was booking on the day of checking in. I stayed there for 3 nights and it was costing me too much. It was like the rates were going like through the roof, like $400 a night. And I was like, I seriously don't know what I'm going to do for accommodation. I've got no housing arrangement whatsoever, and I can't live at a Meriton for $400 a night. So I basically jumped on a website that for roommates. You find people finding roommates.
This is before Airbnb.
Yeah, before Airbnb wasn't around. And I found this guy, this off-campus, a uni student looking for a roommate. I called him up and I said, look, I need something now. And he's like, I'm not expecting any, I'm advertising for a roommate maybe to move in like in a month's time. I'm like, no, but I need a bed to sleep in and it needs to be like tonight.
I'm homeless.
Yeah. And he goes, I can't. And I said, if I give you $100 just for tonight, can I come and stay at your house? And he's like, $100. And I'm like, yeah. And he's like, okay. So I roll my bags from Meriton up to 300 metres up the road to his place because we're living in, this is Macquarie Park, so it's quite high density. There's a lot of apartments and stuff.
Yeah.
And he said, but still, you can't move in yet. I'm not ready. So this is the next day. And I paid him $100 and I'm like, thank you for the place to sleep. Spend a day searching for a more permanent situation, end up finding a roommate who could take me on short notice. And to him, it was also the same. He's like, oh, yeah, when do you want to move in? I'm like, tonight would be great. He's like, what?
It's just me in a bag.
Yeah, it's just me in a bag. I can move in tonight. And he's like, I'm going to need a bond. And I'm like, what? So I went to the ATM and drew out all my money, my savings and stuff. It was $800 bond. That's all I had in my bank account sort of thing. And drew it all out and said, yep. Accommodation sorted, and then I was back into mindset of starting the company and building the company. So that's basically what I did for the next 2 years in Sydney at Paul's, being embedded in his office. He knows nothing about conveyors or anything like that. He knows electronics
he's the
design.
Tech guy.
He's the tech guy, and I'm the conveyor guy. So I had to be in his office working with his engineers on the day-to-day decision-making that needed to go into the design.
How do you get paid then?
We
seed capital.
We built it into the seed round. So the investors said, look, you can't be part-time on this. We're investing in a business that we want you to be fully focused on. And I said, well, to do that, I need a salary. And they said, what are you getting paid now as a graduate engineer? And I said, $65,000 a year. And they said, well, all right. Well, of the 500,000, 65,000 will be your first year's salary. So that's what we did.
And so you had 12 months basically to start getting this product into some sort of design concept that could then be sold.
That's right. And guess what? It actually didn't happen in 12 months. It didn't happen in 4 years. We only got it to a point where it could be sold in late 2018, early 2019. So that's 4 years down the road. And we had to raise another $2 million before we even got it to a point where it could be sold. So
you must have 100% tenacity and about 200% resilience to have gotten to that point.
Yeah, but the signals kept saying you're on the right path, but we hit so many development snags and things wouldn't work, and we would do a deal with the mining company to put some prototypes in their conveyors, and they would not work or not work properly, and then we'd have to investigate why, and analyze the data and go back to the drawing board, and the amount of redesigns we've done. And obviously we're burning cash while we're doing this. So it's like I'm constantly perpetually staring at a cliff face. And it's like, before we get there, we either need to be a profitable company or raise more cash. But you're a green company with a green technology that nobody's seen before. We're not going to give you $1 million just to go and deploy it throughout our conveyor systems. We've got to test it. And we don't want to pay for your test products, your prototypes or anything like that, because there's risk to us. And they're rightly so in the early days, because it didn't work half the time. So
you said 2019 things changed for you. How did that change?
We got the product to a point where it was stable and was working. And then we could say to clients, okay, you're not buying test systems anymore. You're buying a bona fide product that's going to change your conveyors. Something that people operationally adopted and used in their systems as a tool rather than an interesting R&D exercise. I came back to Mackay and moved back in with mum and dad, but we had an office. And that was split spaces, and we were working out in the main co-working area on a desk, just myself. Not long after that, it came time to hire our first employee, and we put a job advert out for a mechanical engineer because all the electronics was taken care of. It was time to start working with integrating our product with the conveyor manufacturers out there around the world, and we were getting a lot of interest to do that. So that involves liaising with their mechanical engineering people, and we needed somebody good with design software, and we hired our first engineer, and then we generated a bit of money and grew the business, and then it was time for the third guy, who's Mark, who you met. He's our commercial manager. He ended up being a judge on a panel at a pitch event here at Split Spaces, and so I pitched the business at the pitch event, and Mark was a judge on the panel. He liked what he heard. Mark was in between things. He had been in a pretty high-profile executive position with another company locally. So he said, how can I get involved? So I said, well, actually, we're looking for somebody to really help us out commercially. And so Mark come on board. So then we were three, and we were three people sitting out in the co-working space, and we got paperwork piling up around us and having phone calls and sales calls and prototypes hanging around. And Deb, the community manager at the time, was tearing her hair out about our untidy space. And it was like, we actually need a proper office that's not in the co-working space.
How have things changed in the last 2 years for Vayeron?
Enormously. We're a real business now. We've got a real org chart now. We have a supply chain, and a lot of the manufacturing of our product was historically done in China. COVID forced a rethink, and so now we are actively probably 60% of the way through our strategy to in-house our manufacturing of our technology. So we're becoming a genuine bona fide manufacturing business. So we've invested in equipment and machinery. We've participated in a collaborative project to manufacture electronics, which we spearheaded the creation of this capability in Mackay, because we saw it not only being a benefit to our business, but other businesses locally that need to make electronics that can't at Mackay, they have to go elsewhere. Why? We should be able to do that in Mackay. So we got involved in driving forward a collaborative project that brought the equipment capability to Mackay so businesses could make electronics here in Mackay. Got on order and soon to be delivered other pieces of equipment that'll be the final piece of the puzzle that'll allow us to make our sensors here locally and not in China. We've always wanted to be a global business, grown locally, headquartered locally, but globally focused. And so right from day one, we've also been generating market opportunities and driving business in other places around the world. And it just so turns out that these markets that seem to be really early and keen adopters of what we're doing are places like Latin America, so Chile, Peru, Canada is also a great market for us, where we've done some business and continue to sort of grow the opportunity in Canada. USA is a bit of a hub for us in terms of accessing the Canadian opportunity or the Latin American opportunity. So we are doing business with conveyor manufacturers in the US. My trip to Chile was all about, we've got a partnership with a company over there, and we've since we've developed our relationship with them, we've actually introduced them to one other local technology company, a company called Two Sensor, who we're friends with. We don't compete with each other, And we said to our friends in Chile that you guys are doing great for us. I think you should bring on one more piece of technology into your portfolio and make that 2-sensor, because the more Mackay companies can build their businesses, their technologies, and then go and make them global successes, the better. And I'm a big fan of that.
Collaboration, I think, is key for us as a human species moving forward.
Yep.
Now, the biggest thing I've taken away from our conversation today is that you started with sensor, a component of a roller for a client who was having big issues. How has your business developed through that one idea? I mean, what other services or products have you been able to develop?
As you go through the journey, you kind of like get exposed to a lot more of you work closely with your customers on your flagship and core technology, which for us is our roller sensor product. But you do get exposed to other problems that they're having and other areas where with very or minimal extra effort, you can probably solve as well, because you've gone and put all this investment and effort into this first product. But in doing that, you've developed a capability. Then it becomes easier to apply that capability and expertise to other problems and solve other additional products that are broadly in the same niche or space that we're currently playing in. We have what's called and I must say it is definitely the consequence of all our focus being on our smart idler technology, which is the roller product. But we've got what's called a wireless acquisition device, which we've abbreviated as WAD, and it's really, really not sexy. But WAD is a generic sensor node that can be applied on a whole variety of different pieces of industrial equipment to gather remote operational data from that equipment and wirelessly report that back for a user to analyze the data and make determinations about how that equipment's operating. And so WAD is kind of like a parent product, and it has children offshoots. So you can give it different personalities by slightly tweaking the software on board WAD. But the first child is a longwall mining monitoring device. So for anybody that doesn't know, longwall equipment are used in underground coal mines, and being underground, operate in a 3D environment. You can kind of go up, down, left and right in all these different directions, and they need to drive this equipment to follow the coal seam. And there's a push by the mining companies to automate this longwall equipment because it's very dangerous to have people down there. But automating it means knowing how all the components of a longwall are operating at any given point in time so that you can drive it properly. And some of it is just very difficult to sensorize. But our longwall inclinometer is a device which can be applied to previously unsensorizable, terrible word, but
you can make it up.
Yeah.
You made up the technology, you can make up words.
Unsensorizable components of the longwall, and they can whack it on in a very plug-and-play style and start immediately gathering positional information on that equipment so that they can feed that into the control system that automates the longwall. But then we thought, well, this is, that's one use case and it's a super niche use case, but there's a whole bunch of other things that we can use this device for. We just need to tweak a couple of things in the software. So the next product is what we call bearing bud. So you can put it on other rotating pieces of equipment that have bearings in them that you need to know the condition of those bearings before they fail and create a really costly
wreak
event.
havoc.
Yeah, that's right. It can be so many other things, and we've now come to the realization we can't go off and chase all these other little applications. We'll go broke and we'll go mad chasing those opportunities. So what we've done is we've decided, well, let's put the power in the hands of the users in how they apply that device. So we're creating, and we're about halfway through, creating a software platform that the user can develop their own unique little application for whatever it may be. You might be in a guy that's interested in monitoring wind turbines in a wind farm without needing to know any programming or software. You can kind of click and drag little modules around and create your own personality for the WAD and upload that personality to that device. Universally, across all the products we develop, we've got ability to produce easy to deploy sensor systems en masse that monitor vibration.
How old are you now?
33.
33.
Yeah.
So this is 12 years on, basically, from when you first came up with a concept idea.
Yeah, when you say it like that, it's scary long, but it doesn't feel like it's been 12 years.
how do you see the next 12 years rolling out for you? Are you looking at early retirement, making your first million? What's the vision?
Yeah, it's a good question. I think about it every now and again. What do we do next? And I think what we do next is we grow Vayer to a point where we're a synonymous brand in our field. That's my goal. I want to be ubiquitous in terms of conveyor monitoring, best practice, and it's what you do when you build conveyors. And we get to a point where we're kind of like truly a global business, maybe a couple of offices in places like Chile and maybe key locations, that sort of thing. And then I don't want to be in the day-to-day. I think we need a proper CEO to come in, and I can maybe take a step back and do some other things. I'm not really sure what those other things are. I think when we get to that point and that kind of maturity, run it as a proper corporate global entity, which is not me. Just make sure that if you do secede to someone, that they don't boot you out entirely. I've heard of that happening. Yeah. We'll definitely make sure there's mechanisms in place to stop that from happening. Yeah. Well, I look forward to hearing the next exciting thing in the Vayer journey. It's been a pleasure getting to know you today. It's Real Podcast. Yeah, thanks, Kim. I really appreciate it. Thanks for having me. If this podcast with Ryan Norris has inspired you to follow through on an idea, or you have questions that need answers, connect with us on our social media, YouTube, Facebook, or of course via our website, projectcatalyst.net.au, where you'll find all of our contact details. Project Catalyst is funded by the partnership between the Australian Government's Reef Trust, the Great Barrier Reef Foundation and the Coca-Cola Foundation, with support from WWF Australia.